Alright guys, so let us talk about solving electron configuration problems. And to solve these problems, there are a few things that you need to know, and that is Aufbau's principle over here. And his principle has to do with these subshells that you see here, which are S, P, D, and F. Electron configurations is pretty much like a roadmap that tells you exactly where the electrons are. And you guys are already familiar with finding out the number of electrons. If I ask you how many electrons does calcium have, you should know that it has 20 electrons. So let's talk about electron configurations. What these here means, this SPDF. These are subshells or suborbitals. And the S suborbital contains a maximum of 2 electrons. Can you see this? This E negative, that is an electron, okay? So the S suborbital contains a maximum of 2 electrons. The D suborbital contains a maximum of 10 electrons. The F suborbital contains a maximum of 14 electrons. That being said, let us come over here to Aufbau's principle. Now you can see this arrow, these lines and the way it's going. It's pretty much showing you how to order the suborbitals in order. All right, so the first suborbital is the 1s, all right, followed by the 2s and then the 2p. Okay, this order is very, very important. If you do the wrong order, if you go this way, you're gonna get the wrong answer. Okay, you must follow this line right here. You must. Okay. And I have listed a few of them out right here for you. Okay, so can you see that the first, which is the 1s, that's the first one over here. The 2s, which is next, that is over here. The 2p is over here. The 3s over here. Okay, so I followed these in order. If you know how to follow this in order, then you already know everything about electron configuration. So let's talk about this some more. If I'm to ask you a question and I tell you what is the electron configuration of hydrogen, okay, all you need to do is look on your periodic table and find out how many electrons does hydrogen have. And hydrogen has 1 electron, okay? So we're going to do this in order, and the first suborbital that you see here is 1s. All right, so we're going to put 1s. And we're going to put 1 up here, okay? This number up here signifies the number of electrons. And if you remember, the s suborbital contains a maximum of 2 electrons, okay? You can't put more than 2 electrons in there. This here is the electron configuration of hydrogen. If I ask you what is the electron configuration of helium, helium is right here, and it has 2 electrons, okay? So we're going to do the same thing. We're going to fill in our electrons into these orbitals. And we know that the 1s is the first one, and the s suborbital contains a maximum of 2 electrons, all right? So we're going to fill that out. 1s2. It contains a maximum of 2 electrons. If I ask you what is the electron configuration of lithium, lithium is over here. How many electrons does lithium have? You know that lithium has 3 electrons, okay? So we're gonna do our 1s and we're gonna go in this order, all right? So 1s, and we're gonna have to fill out the 2. So since lithium has 3 electrons, we're gonna be doing this up to the point in which we get the number 3, okay? So 1s2. Now we have filled up our 1s orbital, okay? So after we fill this up, we have to go in order. And the next that is on our list is over here, 2s2. Now don't go from 1s to 2p. Yeah, you need to go in order, okay? So we're done with the 1s subshell, and then now we need to go to the 2s. And how many electrons do you think is going to go here? Remember, we're doing this all the way until we reach 3 electrons. Currently we have 2, and what's next is 1 electron. And that is the electron configuration of lithium. And then we have, let's do the electron configuration of calcium. To do the electron configuration of calcium, you need to know how many electrons calcium has, and calcium has 20 electrons. All right, so we're going to do this all the way till we reach 20 electrons. All right, so we're doing the electron configuration of Ca, calcium. So we're going to start off with our 1s. And how many electrons goes into 1s? If you look over here, the s contains a maximum of 2 electrons, okay? So we can fill that up, 2. So we're trying to go all the way to 20, and currently we have 2, so how much is left is 18, all right? So what's next is our 2s, all right? So I'm going to put 2s, and how many electrons are you going to put there? You can pause this video and think about it. Boom, we're back. It contains a maximum of 2 electrons, okay? So currently we have 4 electrons. And going in order, we've gone through our 1s, we've gone through our 2s, and now we're going to 2p. Okay, so that's what we're going to put next, 2p. And remember, the p subshell has a maximum of 6 electrons. And we're doing this all the way till we reach 20, and currently we have 6, all right? So we're going to have to fill up our p. And it contains a maximum of 6, okay? When I say contains a maximum of 6, really, so it can actually contain less than 6, okay? It's actually possible for it to contain 4 electrons, okay? And if this is our electron configuration, this would not be calcium. This will be whatever element has an atomic number of 8. So the element that has an atomic number of 8 is oxygen. So what we've actually just made right now, I know I'm going on a tangent, what we just made right now is oxygen, okay? If I was to ask you what is the electron configuration of oxygen, this is it. Because this electron configuration has 8 electrons, all right? But let's continue all the way till we reach calcium. So after, and we need to change this to 6, okay? We need to fill up our subshells before we go to the next one. So we've gone through our 2p6, boom. And then what's next is our 3s. Okay, so we need to fill out the 3s. 3s. And the s subshell contains a maximum of 2 electrons. Alright, so we can put 2. So currently we have 6 plus 2, sorry, 2 plus 2, which is 4, plus 6, 4 plus 6, 10. And then plus 2, okay, and that is 12. So currently we have 12 electrons, and let's continue, let's move on. So after our 3s, we need to go to our 3p, all right? So 3p. So how many electrons are we going to put in 3p? Remember, our p subshell contains a maximum of 6 electrons, and currently we have 12. So if we add 6 plus 12, will we have 12, 13, 14, 15, 16, 17, 18. We'll have 18. So if we put a 6 here, currently we have 18 electrons. Let me move all of this to... Oh no, I can't do that now. So currently we have 18 electrons, right? Oops. Alright. So currently we have 18 electrons. And we're trying to get to 20. So we have gone through our 3p, okay? Next is 4s, okay? So we're going to put our 4s, and the s contains a maximum of 2 electrons, okay? And that is actually the exact amount that we need in order to make calcium. So we have just created the electron configuration of calcium. If I did not tell you that this was calcium, let's erase that. If I didn't tell you that this was calcium, and I just gave you this random electron configuration right here, there are questions where I'll say, tell me what element this is. And an easy way to do that is just to count up your electrons, okay? These numbers up here signifies your electrons. When you count those all up, that will tell you the electron configuration of that element. Can you guys tell me the electron configuration of this element here? You can pause the video and let me know. So if you've paused this video and you're back to find out the electron configuration of this element, you simply add up all of the exponents that you see here, because these exponents tells you the the number of electrons that is in here. Now I haven't really found out what element it is, but let me see. Stops at 5. It's gonna take me a while to add this up. Leave me alone. Let's continue. Sometimes you also find a question that asks you to draw the orbital diagram. All right, and drawing orbital diagram is very simple. All we're doing is actually drawing the electrons ourselves. So you can see the 1s orbital over here. You can see the 2s over here. You can see the 2p over here. Each of these orbitals, that is these over here, each of these orbitals, you can only put a maximum of 2 electrons in each one. Okay, if I ask you to draw the orbital diagram of magnesium, for example, remember, each of these only contains a maximum of 2. So we're just adding up electrons in here, all right? So magnesium in total has Mg, right here, 12 electrons. So we're filling this up all the way to 12 electrons, all right? So the 1s contains a maximum of 2 electrons, boom. The 2s contains a maximum of 2 electrons, boom. And these lines that I'm drawing here, these signifies electrons, all right? So currently we have 2, 4, 6, 8, 10, 12. These are just extra orbitals. We don't need to fill those out. So this here is the orbital diagram of magnesium. That's pretty much it. Have fun, you guys.